Thank you, Susan. Testing here. Okay, as Susan said, I'm Steve Ruberg. I work for NOAA's Great Lakes Environmental Research Lab. And sort of our role in the Great Lakes is ecosystem as it relates to, one of the things that we do, we've developed like the lake circulation models, we've developed a hypoxia model for Central Erie, HAB forecasting, things like that. So those are some of the things we do, and this is a technology project that I've been working on, but one public service announcement, I know a lot of people in the room and people are like, what the hell is this big Band-Aid on your face? So I had a minor operation that's fine, but I just wanted to make that clear because yesterday was St. Patrick's Day, and I didn't want people to think that I was, spent too much time in the Irish pub or something like that. So that's what it's for. Okay, so notice that I'm underlining towards because we haven't gotten any of these vehicles under ice. We did deploy one of the vehicles in winter, and I'll talk about that. But I'm going to talk about these three vehicles: the Slocum Glider, the Saab Sabertooth, and the Monterey Bay Aquarium Research Institute long-range AUV. So just some of the folks that I've been working with. I'm going to look at it here rather than up there. Just some of the folks in our group. Christian Rozier has been really important in getting sort of a lot of this acoustics data processed. We had acoustics on all of these vehicles, fisheries acoustics. And then also I want to point out that Pete and I co-wrote the proposal for this first project on the Saab Sabertooth. But then others have worked with Woods Hole. I've worked with some folks. I'm working with Aaron Fisk at University of Windsor, Russ Miller at Cooperative Institute. I won't name them all, but and then some folks associated with the Saab project. They're Saab engineers and that sort of thing. So 3 projects, 3 different things that we're trying to do to try to get winter observations. So this was from my ocean sciences talk. I see a couple of people who I met for the first time at Ocean Sciences who were working with Pete. But and so this is an image from 2015. But the idea is that we're trying to get observations in the wintertime. And I've recently been serving on the International Joint Commission winter science group, and so it's been on my mind a lot, and then these vehicles are hopefully in the future going to get us out in a situation where we can get data in the wintertime. These systems may make winter observations more achievable. Okay, so I just want to point out real quick, this is the block diagram of the vehicle, just that you have this positioning system here, which for this vehicle was incredibly key to making this project happen. These are the sensors, a laser scanner for bottom observations, a multi-beam for bottom observations, and then a ASL acoustic zooplankton fish profiler. This one was a 4-frequency unit that we had on the vehicle. This one we own, and then a CTD, a self-recording CTD. So the positioning system is key. Highly, in this case, this one has this really accurate fiber optic gyro system, which helps us get in and out of the channel, helped us. But we're transferring some of the data into our real-time coastal observation network. To me, that's key in the future, in that if we're pulling this data off, we can get it into the system and we can begin using it right away. That hasn't been the case for all of these systems. Did I skip one? I did. So just pointing out the project goals were to navigate this, in this particular case, this is on Lake Michigan, navigate out of the Muskegon Channel, come back, do autonomous docking. That middle picture there is a docking station. Let's do this. Oh, okay, it doesn't work. I wanted to get the video running, but that's okay. And then collect data, multi-beam data, laser scanner data, imagery, and then the fish and zooplankton data. And that system on the left there is a big, giant hydrogen fuel cell. It weighs about 14,000 pounds. And we use that to partially recharge this battery-operated vehicle. The vehicle normally has about a 13-hour duration where it can go out and come back in. This would allow us to make the system deploy it and make it more permanent in a location. It could recharge weekly for about 12 weeks with a system like that. That was actually an add-on that the Navy wanted to test it, and they tested it in this situation. Okay, so we succeeded in getting out of the channel, collecting data, coming back. We collected fisheries acoustics. The big part of this was the engineering part of getting it out of the channel and back. That was not terribly smooth. It took about 7 days of Saab engineers. Hibbard Inshore was the key contractor on this. They're actually in Southeast Michigan. They know more about this vehicle than probably anybody in the world. But we got the sensors integrated. That was a success. What you're looking at here, the heavy line on the bottom is the 4-frequency acoustic zooplankton fish profiler, but that's really not the bottom, that's the surface. There's a little bit of bubbles. We're not really seeing much in the way of fish, but just proving that we could actually get out there and collect that data. That was the research part of this. So we also collected multi-beam data at about 20 meters here. This is the multi-beam data. And then, these are the track lines. You don't have these big wandering semicircles when you come back. It actually can go out there and rotate it on its own axis and make these nice, neat lines. The red is a little shallower than the blue. Not great data that says anything about mussel concentrations. And then we were able to, at a lower level, fly over that and collect this laser scanner imagery, which was in this case just some sand waves. Okay, so just to summarize this very quickly, we deployed this December 7 and 8 in 2022. For a couple of days, we were able to get out, get back into the channel. We got within, with that really accurate positioning system, got within about 2 meters of the docking station. Once it's near the docking station, then it has these hydrophones that are able to, within 2 centimeters, accurately place it, and it autonomously pulled in, delivered its data to our real-time coastal observation network, delivered some of its data, not all of it. And we did that multiple times, and just to make a long story short, it's a reasonable technology, reasonable in that it worked. The price point is probably pretty high. Okay, so the next project, I'll talk about that really at the end to summarize. The next project is with this Monterey Bay Aquarium Research Institute long-range AUV. There's a couple of them there. Pete will be familiar with these. He used those more than we did this summer. But this was associated with Ed Rutherford's larval fish project. We were able to get out and do some ground truthing for Ed. We didn't get to do the ground truthing that we wanted to do for the acoustic zooplankton fish profiler. We're going to change things up this summer and actually turn things around and actually have the research vessel with the plankton survey system and the fisheries acoustic system on the vessel be used to actually get ground truth for the glider system, not this Monterey Bay Aquarium, not this long-range AUV. So it had an EK80 system on it that had split frequency 2 and 320 kilohertz, and then CTDs and echo pucks and measuring chlorophyll and things like that. The idea was to run through this let's call it a blob of fish that Mark Rowe was modeling. And we kind of did that. We were on the Muskegon transect. We deployed it and retrieved it from the beach, which was really great. And some of the EK80 fisheries acoustics. This is the upward-looking system. This was on a day when we couldn't get out with the boat, so these are all bubbles. So big waves were happening. We had a big upwelling that day. Ed's going to talk more about that in his talk tomorrow morning. And this was in the evening, but still daylight, and you have fish down here, likely alewife, Doran Mason tells me. So there's an upward-looking one, there's a downward-looking one. We're in about 17 or 18 meters of water. And then here's nighttime, and the fish are now up in the water column, kind of near where the thermocline was that day, or where the chlorophyll layer was that day. And then here we are in the next morning, and the fish are back down there closer to the bottom. So we were pretty excited about those results. The next thing that we did later that summer is deploy a Slocum glider. This one is actually owned by Aaron Fisk at the University of Windsor, but operated by Russ Miller in our Cooperative Institute. And this is all funding this was all funded by, at least the first project was a NOAA funded project. This one is funded by the Cooperative Institute, or this one is funded by the Great Lakes Restoration Initiative. So it's a glider with an acoustic zooplankton fish profile on it, profiler on it, similar to the one that we put on the Saab Sabertooth, but this is a 3-frequency version rather than the 4-frequency version. By the way, that EK80, that was the 200 kilohertz version, or the data you were seeing was the 200 kilohertz data. We've only scratched the surface on this. We deployed it for about 3 weeks and got it out end of July, beginning of August. And we're really just now processing the data on this, or putting together the processing of the data. It's not real straightforward. We're working with Christian Rice and Reese and Tony Costio at NOAA's Southwest Fisheries Center. The fisheries data is collected separately from the system navigation data, and so in order to join the latitude, longitude, depth back together with the fisheries acoustics, you have to go through quite a bit of processing. So we're working with some folks who created this toolbox out of Spain, and it's going well, but no data to show at this point in time. Just as an aside, I forget her name, but Sheehan out of Rutgers actually did something like this, but with something called Echo Pipe, which is another way of processing the data. We're going to be using Echo View to process this data, but no data to show today. Okay, so next steps. What I'm proposing to do, or what is funded, is complete the AZEFP glider and data analysis from last year. But then by the time we get that done, we're going to be back out in June doing the same thing, and we should have the ability to process that data much more quickly. And that's with Ed, and this time, again, as I said, we're kind of flipping that around in that we are using those Ed's larval fish work to more purposefully do the ground truthing for this AZFP on the glider. And so then the next steps on this, and the reason we're doing all this ground truthing is that we're really on the hook to deploy the glider in the Central Basin of Lake Erie in January of 2025. So hopefully January, February, March, one of those months, or probably not all of them. We're working with the United States Coast Guard. They've agreed to have us, allow us to work up their vessels. This is something that Mike McKay at the University of Windsor has been doing for quite some time. Mike is kind of leading the sort of standard data collection for water quality analyses, and he's funded to do the Central Basin of Lake Erie project, as well as Steve is funded to do Lake Michigan for a couple of months in the winter, Steve Potvin. And so Russ Miller is helping with this, and then Commander Peace with the United States Coast Guard is helping us make this happen. So that's our way to get out there in the winter. At this point in time, the Morro Bay is an icebreaker. That's a nice thing to have access to in the winter. Okay, so I'm proposing that we'll get that Saab Sabertooth back out in the winter of 2026. That's the hope, and that's going to be NOAA funded. Okay, so the glider is fairly easy to deploy. Russ Miller really is the glider king of the Great Lakes, in my opinion. I know others are doing gliders, but he really has this dialed in, and putting the fisheries acoustics on there, the one from the University of Windsor, is not that big of a stretch. And so the bigger stretch is processing the data. But that probably is going to be our workhorse for open waters in the wintertime. We're not going to try to get that up under ice. As I mentioned, this vehicle I'm hoping to get back out in 2026. The strength of it, you can put a lot of sensors on it. It has a lot of power, and that docking station really just kind of turns it into something that can be more persistent. It can be out there more frequently or for longer periods. And then the long-range AUV is called long-range because you can get about 10 days out of it. Mike Jakuba from Woods Hole, who I'm working with on this, is determined to get this up under ice. So hopefully next January we actually can come back and say that we got a vehicle under ice for doing these broad spatial observations of winter ecosystems that we currently are not getting because of winter and ice cover and things like that. So that is probably it.